Hey, it's Alex Williams of the New Stack. Welcome to the New Stack Makers, a podcast where we talk about application development, deployment, and management at scale. Cloudbees Jenkins X has a new UI made for the demands of continuous development. Learn more about Cloudbees, Jenkins X, and the Cloudbees leadership in CI/CD at cloudbees.com. So we're here at KubeCon, and I'm here with Gareth Rushgrove, Director of Product Marketing at Snyk. I've known Gareth for several years now, and he's one of the more, I would say, academic types of this space, a thinker. And I'm curious on that interest in your curiosity about how organizations work and how technology is developed. Was that one reason what brought you to Snyk? I was curious about that because you do like to explore topics and you do like to think about them and write about them.
Yeah, definitely. I do like digging into a deep topic. It's a good start. I think my interest in Snyk was basically that I've done bits and pieces around security, mainly when I worked for the UK government. I've been a developer, but also been responsible for developer tools like Docker. And Snyk's in this interesting position where we're building a software company that's fundamentally focused on developers, but addressing a security problem. And we're helping open source communities do those things. And all of that confluence of those topics was sort of well, wait a minute, I like all of these things. They're all interesting. They're all differently interesting.
So security firms are known for publishing reports, and you guys and you are involved in publishing these reports. And there's this recent report that you developed, a security report on Helm. And the question is, for us, and the one we've posed actually, and we'd love to discuss about it, is Helm really insecure by default, or just all technology is secure by default?
So the report we've just done was looking at the security of the Helm chart repositories. So there's loads of shared content. And the first thing there is that basically any sharing of third-party content poses a potential risk. Ultimately, what you're doing is you're sacrificing the fact you didn't write that code for when someone's already written it. I can use it right now, and that's ultimately how we build software today. Most of the code people are running in any of their applications, they didn't write. It's Linux. It's the massive ecosystem of NPM packages or Java packages, or Ruby packages, or containers, Docker Hub, etc. And Helm is just part of that cycle. It's definitely not a security problem with Helm. It's a trade-offs with third-party content. You want to know, are they secure? It's a good way of deciding whether something is to use. How do I choose between this chart and this chart? Or how do I choose between this package and this package? Knowing whether it's secure is a good sort of thing to consider.
Yeah, I mean, it has to be considered, especially now that I think what you're saying is the software supply chain, so to speak, has all kinds of vulnerabilities that are just far and wide now because the attack surfaces have changed so much.
Yeah, and I think we think, I guess the term software supply chain has been around for a while, and people often think of it as quite a sort of narrow, more like a sort of CI pipeline. The reality, it fans out incredibly quickly.
Yeah, it's like a mesh almost, software supply.
Most people cannot answer the question how many component parts go into even a single microservice. Combine multiple microservices, it becomes really difficult to answer those types of questions with the tooling we typically use today.
I think it was actually you I was having a conversation with a few years ago about this issue now we have with dependencies, right? It's you can write the code, and the code may only be a few lines, but there's all these dependencies associated with the code. Yeah. And that's kind of the crux of it.
Yeah, but we're doing that because that's actually a way of building on the shoulders of people who knew that domain.
Exactly.
Well. So yeah, the reason we looked at Helm was that it's really successful at doing that. Installing things on Kubernetes is not necessarily simple. Helm install MySQL is definitely simple. And obviously you sacrifice something for that. You have chosen a higher level abstraction, but you've done it because it's someone else knew what they were doing. We're just trying to help that abstraction not bite you from a security perspective.
So Snyk, as a company, has released several products now, really, aimed at detecting and remediating security vulnerabilities. And you've done it for Java, you've done it for Python, you've done it for container and Kubernetes. And I guess the question is, what are the underlying security issues you are addressing, with these third-party repositories that you're developing?
Part of it is visibility, and that visibility to what you're using, and what you're using indirectly. So transitive dependencies are a really sort of common source of vulnerabilities. Some of the research we've done, like upwards of 80% of the vulnerabilities actually come from transitive dependencies. They're things not that you chose to include, but something that the things you chose to include included, potentially down a tree of many dependencies. So some of it's the visibility of what you're using. With that comes, well, what vulnerabilities do they have? There are large public data sets of vulnerabilities. There's also a lot of just conversations that don't make it into those like public repositories like CVE. There's generally been a high barrier to entry to getting a CVE number, and it takes time as well. You sort of want to know that that conversation on that mailing list about a security problem, that the project was like, oh, thanks for telling us, we fixed it. You want to know about that as well, so you know to update to the latest version, or that you can mitigate that problem in some other way. Maybe it's, yes, you have a known vulnerability in that application, but I can actually, I can configure my network in a different way that means that won't happen. Or I can add extra monitoring, so yeah, it's a problem where it doesn't have a fix yet. I'm going to watch it a bit more closely.
So getting back to Helm, though, you did just release this report on Helm chart security,
Yep.
as we were saying. What did you turn up? Why did you turn your sights to Helm?
And the main reason to look is that it's popular and no one had done so as far as we could tell. The issue there, and this is a sort of classic security problem, is that if no one's looking, then no one's really thinking about it. Maybe apart from the types of people who will look and not tell anyone, and they're the attackers. Attackers don't tell people about vulnerabilities. They look, hoard them, and use them. And it's much better from a security perspective to look and make people aware. So partly we want to drive an awareness, and I want to shout out to Matt Farina and Matt Butcher and Matt Fisher and a number of the other Helm org maintainers.
They've done a great job.
They've been super responsive. They didn't ever think oh, this is a security vendor doing a bunch of FUD about why Helm is bad. They were like, fantastic, how do we then make this better? And that's super mature from an open source project. So I think it is about that visibility, it's about the conversation. In terms of specific things that came up, and some of it was just that, well, what's the baseline? How many vulnerabilities are there and how many of the charts are vulnerable? I think that's more interesting over time. Realistically, if no one's looked, that's always high, similar to Docker projects or Python projects. It's not specific to Helm. More interesting were things where actually, I think we saw 65% or so of the charts, if they were to update to the latest available images, would reduce the number of vulnerabilities in them.
Sure.
And I think one of the things that can kick off in the Helm community is actually, how do we incentivize chart maintainers to keep up to date? Again, at the moment that's not visible. How far behind are different projects with the upstream images? Maybe making that visible and incentivizing it and even gamifying it makes it something that actually becomes more the norm. And if you can keep up to date, you can often reduce vulnerabilities quite considerably.
Well, I mean, it's reminiscent of Docker images. I mean, if people use official images, then there would most likely not be as many vulnerabilities that we see.
Well,
Or they wouldn't be popping up in there.
well, using images from a trusted source is definitely, again, I think you go down, you build these heuristics around, should I use this or not? Because you're making that trade-off of going, it's going to be faster, but what does it cost me? So understanding something coming from a trusted source is a good proxy. But also, are you using the latest one from that trusted source?
Yeah.
It's not enough to be, well, yeah, I'm using something from a trusted source, but it's 3 years old.
Right.
Actually having processes and procedures to keep things up to date is really important. And that's that classic ops problem of patching. What we're talking about in the context of the Helm charts is a similar problem, but remember that it's an open source community. So a lot of that is making things visible is important.
So if the maintainers make it visible, then the hope and aspiration is that the people who are users of the Helm charts will then follow and update and
It's multi-layered, I think. I think if there's visibility within the Helm sort of maintainer community, the people who maintain all of the public charts, then it's easy because you can sort of go, oh, yep, that's out of date. I didn't know. Now I can just do it. Rather than needing to find out and think about it, someone said, like, here's a list of things to do. That makes it easy to do them, assuming you have the time. From a user's perspective, we can start looking at them judging charts ultimately by, well, actually, should I use this or not, based on how well maintained it is. The Helm community actually has a good list of sort of things that make into this, like they've got a process for going through sort of incubating charts and moving them into the stable repository. But they don't quite have the tooling yet to make that super visible. And as an end user, knowing that this has been maintained, knowing someone's keeping up to date with it, knowing if there are vulnerabilities announced in dependencies that they're being updated, gives me confidence to use that. So I think as end users, it's a good thing to see as well.
So how do your scanning tools come into play here?
Snyk basically has a very large database of vulnerabilities. We normalize from all over the place and really sort of make the metadata more usable. So we provide that as a software as a service. We then have built lots of tools on top for scanning Ruby projects or scanning projects in GitHub or scanning containers from registries. All we've done here is really extend that to what does that mean for Helm? So a Helm chart is really a set of manifests, Kubernetes configuration, templatized, and a set of values that are basically then interpolated with that to give you the config that is then deployed onto your system. All we've done is basically built a simple plugin that really renders that template, extracts out the images, which images are being used by that chart, and then puts those through Snyk's security analysis and then gives you that information back. And we built that tool to aid the research in the report. Actually, we just generate a load of data and then did a bunch of data analysis on it. But we've made the tool available so anyone who is using Helm, building charts internally, not ones in the public repository, can use it. You just run Helm Snyk test, point it at your chart, and you'll get a bunch of vulnerability information back.
Why'd you decide to focus on Helm chart? You mentioned that it hadn't received a lot of attention in this realm. What are the other factors that you think about across the community? For example, the use of YAML, for instance, and how it's become so predominant in Kubernetes and cloud-native architecture.
So one of the things we didn't look at this time, for this report, we've ended up focusing on the vulnerabilities in the images being brought in by the charts. But there's actually another aspect of configuration there. Like, it's not enough to just think about images when we talk about container security. Increasingly, we've got all of that configuration, whether it's in Helm charts or whether it's just in your repositories, or whether you're using a high-level tool to manage it. There's a lot of security issues there, and ultimately the Kubernetes system, the defaults are not that secure. So by default, things might be running as root. They're running with readable and writable file systems. And nudging people towards really starting to secure their configuration better as well as their images is also something that we're super interested in. Actually, we have all the data for the Helm charts around like where they're using pod security policies and where they're running things as privileged and where they're like not setting CPU group limits and memory limits and the like. And we'll probably do some analysis around that later as well.
Interesting. So as you think about what you offer at Snyk and you look at your peers out in the market, there's a lot more scanning tools out there. How do you view the landscape, across yourself and your peers?
I think there's like scanning's really just sort of one of those things that everyone does in some way, that everyone does it slightly differently. I think most of what we focus on are the developers. So what we see, I guess, in lots of cases is basically like responsibility shifting to development groups. Like security has obviously been a part of that, and I think organizations are often set up such that development is incentivized to go fast and security is incentivized to make sure there are zero issues, and they fight. Classic sort of DevOps conversation around misaligned incentives. What we're seeing, and the DevOps report from like Dora and others, like if you can actually move security to be something that's dealt with in the same group, the incentives are aligned, and you can start saying, well, okay, you force the trade-offs to be made in one place, so you can have speed and security at the same time if it's dealt with in the same place. But that group of people, really the tools that were built for a different generation and a different set of users, like a security user, are different to something that's like really useful for a developer. And so Snyk's been building that sort of generation of security tools as security is shifting to developers in larger organizations. But other things are shifting to developers too. So software packaging, definitely something that was done in the IT org in a corner somewhere. Well, what's Dockerfile if not software packaging shifting to developers? Configuration management, again, part of definitely something that you did in IT in academic circles as well. What is all of this all this YAML files that developers are writing if not configuration management shifting to developers? On the packaging side and on the config side, I'd say we haven't yet got the tooling for developers, and that's where it's happening. And I think that's our focus. Like we're much more involved in, I guess, local tooling, CLI tooling, IDE integrations, in source control systems, in CI systems, really trying to shift security left. There are also, and that's not the only like areas where you need security. There's a whole bunch of areas where it is a classic operations problem. It's a network security issue. And I guess like some of the folks focus more there. Everyone sort of meets in the middle with registries. Registries have become something all the cloud providers basically have to have. They're there. All the platforms on-prem Kubernetes distributions have a registry. There's Harbor is there in the CNCF. Quay is obviously now newly open source. Registries are something that are sort of everywhere. They make a nice, useful place to sort of integrate security tools. And so everyone does that. Everyone sort of meets there. So the overlap with registries container security scanning is sort of, everyone has that. Both security vendors, cloud vendors, the open source projects like Harbor. But there's more of an interesting split between are people doing things mainly on the network level in production or actually focused on developers where you can like fix problems quicker.
So what are you finding in terms of how developers are using Helm charts to package, their applications on Kubernetes? And you're talking about this being, a new practice really for developers to be engaged in configuration management, and they're doing that through YAML. And how does that open their application to possible vulnerabilities?
Well, basically by opening up the sort of another set of dependencies in lots of cases. So again, if they're writing the Helm chart from scratch, maybe they'll make mistakes around the configuration. So again, they might not be domain experts in Kubernetes config because there's not actually that many of those people. It's very easy to not add certain properties or just solve your problem by making the pod privileged, because then it can do everything versus locking things down and understanding capabilities. So part of it's that domain knowledge. The other part is that often your application will have some dependencies. Maybe you need a Redis instance and a Postgres database. And well, Helm makes it incredibly simple to use those. Like you'll just really be doing sort of Helm install Postgres or Helm install Redis. And it's that. How do you understand the vulnerabilities introduced by the dependent services that you've just... Kubernetes makes it very easy to bring those in. Helm makes it very easy for you to do that with nearly no work. But is that Redis instance actually going to be secure? Even if your application, the code you wrote is perfect and all of the dependencies in it have no vulnerabilities, well, you brought something else in from somewhere else and that has a vulnerability and that gets you. So security is really holistic.
Yeah.
It's nearly never enough to just go like, my bit of the world is secure, then therefore it's fine.
So you came at this number in the report on stating that 68% of stable Helm charts contain an image with a high security vulnerability. How did you arrive at that number, and what does it mean specifically to you, and what are you assessing there? Is this then get back to what you're talking about here with like it could be really dependency? It's really the root of it is dependencies?
Well, it's the same issue you have just generally with shared third-party content in package repositories, and here we're talking about shared container images. I think the number is actually most interesting from the point of view of a baseline, not as an absolute sort of number or an indication of good or bad. The reality with security is if no one's looked, it's easy for things to be bad.
Yeah.
It's just like
It's like growth of a company in the first 2 years. It can grow 500%, but what does that mean?
Yeah. Without looking, then security is not often the top of mind
Right.
thing. So I think it's a useful baseline. I don't think it says like someone saying, "Oh, that means Helm is therefore insecure," is not paying attention to the rest of the world, because what they're probably saying is the alternative is write everything from scratch yourself. It's like, well, yeah, but that's really expensive. Security isn't a binary thing that you take. It's something that you invest in, and ultimately you choose how much to invest in based on your context. I've worked in environments where security wasn't the priority because it wasn't. Like often a startup organization, the thing that's going to get you is not going to be the security problem.
Right.
I've worked for the UK government where actually there were areas there where that was also true.
Yeah.
But also I've worked on some things where that was definitely true.
Yeah.
And you have a budget, generally speaking.
Yeah.
And how much of your budget are you going to spend? And I think that number is interesting, mainly in the context of what does it look like in a year. So we've highlighted this. We've got some tools now to sort of measure these types of things that we're providing to the Helm community. I hope actually one of the other things that happened recently was the Helm project itself went through a security audit, which was really good. Like all that's published. That led to some changes. So I think that security in this maturing ecosystem and project, what does this look like in a year? Like, what does the community look like? What do the tools look like? Not just from us, but from others as well.
So I think this kind of sums up I think how we would like to just conclude is on prevention and remediation. And I think I get a hint of what we're talking about here. Snyk provides this plugin, for example, that can be used for scanning, for instance. There are things to think about in the overall Kubernetes community, because we are essentially kind of working on the shoulders of giants, so to speak, the ones who've been developing these architectures for many years, and now there's all these dependencies associated with them, but that doesn't necessarily guarantee security. So what are some of the things that you think about for prevention and remediation to improve security overall as we go into like this just hyper speed, age of application development?
I think that speed is the problem. And that's often been the classic sort of security problems. Is like, if we can slow things down, we can make everything secure. It's like, no. Like, you can't slow things down. What can you do at the speed we're working at? And we're working faster than ever, and in open source communities and just generally in software. I think the only way of addressing that is automation.
Can you put curves in the road, so to speak, symbolically?
I think it's...
Or is that just, or would they learn how to take the curves even faster?
I think that, and there's an aspect of that, but change at scale is really hard. So I think the more we automate aspects of this, that's really like the way we've, as a society, often been able to like make that next leap to something where, yes, we're not sacrificing whatever it was we cared about, but we're also making something better. So I think that how we automate some of these problems is sort of that's an
algorithmic issue.
Well, no, I think it's a user problem. It's a user experience problem. So something we've done really well with application vulnerabilities has been simply sending pull requests. So yes, we can tell you have some vulnerabilities, but actually we can send you a pull request to fix them. So if you've got a vulnerable package in your project.json file, you can get a pull request from Snyk that will basically tell you that there's a vulnerability, tell you that there's a fix in this version, and send you a pull request. So at that point, you're like, well, I know there's a problem. I know there's a fix. And the computer is basically a combination of all these different bits of software has said, all I need to do to fix that is click a button. And all of those steps were manually possible before. But I don't need to care about that. Like, we've moved to an automated model. And I think like the more we can automate some of these things where it's like, we know what you do step 1, step 2, step 3, step 4. Computers can do that better than us.
Yeah. Well, Gareth, thank you so much for taking some time. I've been joined by Gareth Rushgrove, who is with Snyk, and we've been talking about the security report that Snyk has published on Helm charts specifically. And we've covered a lot of ground here on kind of the issues with dependencies, on developers becoming far more involved in configuration management and the opportunities and issues that surfaces, and looking at different ways we can prevent and remediate these issues. So thank you so much.
Yeah, good to chat as always.
Yeah. Cloud-based Jenkins X has a new UI made for the demands of continuous development. Learn more about Cloud-based Jenkins X and the Cloud-based leadership in CI/CD at cloudbees.com. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.